Hello students, I am Ms. Pooja Kalange, Assistant Professor IISM RNC. Welcome you back to this video lecture on transportation problem. So in the previous part of transportation problem, we have seen how to get the IBFS using RAM method, and now we'll be finding out the optimal solution using Modi method. So if you remember, this is the same problem which I have covered in the part 1. Okay, so this is the whatever the allocations we have got for the um, given problem using the RAM method. So you can see here the total allocations done here are 7. Sorry, 3, 4, 5. Okay, 7 allocations have been done. Okay, and we had calculated the IBFS as 290 units. Now you have to solve this problem for optimal solution for optimization using Modi method. So let's see what is the first step. And the first step is you need to check the acceptability of this solution. That is, you have to check whether the given solution is correct or not, or the given allocations are done correct or not. So for that case, we need to check the number of allocations using the formula m plus n minus 1. That is number of rows, number of columns minus 1. So 3 plus 5 minus 8, that equals to 7. So you should have 7 number of allocations. So here you can see you are already having 7 number of allocations. So the given solution or the given IBFS is acceptable. Okay. Now next is we have to calculate the net cost change, or you can say first we need to calculate the values of rows and column. Now this method is also said to be the UV method, where U denotes the rows and V denotes the columns. But instead of this, the book which I preferred, I have taken the R and the K values I've taught you in the same way in the lectures. So instead of U, we will be taking this as R variable, and for columns instead of V, we will be taking it as K variable. Just to clear your doubt that UV method is same what I'm telling you here, okay? So first what we need to do is we have to allocate R and K. So you can see here I've allocated R1, R2, R3 for rows and K1, K2, K3, K4, 5 for columns. Now in this case you have to consider a row or column with maximum number of allocations, or by the stepping stone method you can just consider this as R1 equals to 0. But in this case I'm considering R3 equal to 0 because row number 3 is having the maximum number of allocations. So if you know R3 equal to 0, you can calculate K5, you can calculate your K3, and you can calculate K1. Okay. So in this way, first we will be calculating the rows and column value. In this case, we'll be using the formula is Ri plus Kj is equal to Cij. Cij is nothing the cost which is present at that particular cell. So now if you see this values, we are calculating only for the stone square, means the allocated cells. So total we have 7 allocated cells if you see here, okay. So these are the 7 allocated cells: 1, 2, 3, 4, 5, 6 and 7. So there will be allocation values you'll be getting here at this is 1 2, this is 1 5, this is 2 1, this is 2 4, this is 3 1, this is 3 3, and this is 3 5. Okay. So based on this stone squares, we are going to calculate the values of Ri plus Kj. So the formula, as I've told you here, it is going to be Ri plus Kj is equal to Cij. So we are calculating these values for stone square, that is the allocated cell. So since we are considering R3 equal to 0, so C31 is equal to R3 plus K1. So I'll just tell you here, see the C31 value here, okay, so this is C31. The cost here is 3 and the allocated here is 5 value. So we will be considering the Ri plus Kj. So this is R3 and this is K1, okay. So this will be R31. So R3 plus K1 equals to the cost, that is 3, okay. So what will happen here? We'll be getting this as R3 plus K1, that is 3 equals to 0 plus K1, therefore K1 equals to 3. Similarly C33, so C33 if you see here, sorry I've just missed out the labels here, so I'm just referring the upper table. So C33 if you see here, this is going to be, the cost here is 2, you can get the value of K3, okay. So in this case I've written here the values also, so you can see here. So R3 plus K3, that is C equal to C33. C33 value is 2. So 0 plus K3 equals to 2. Similarly, C35, R3 plus K5, that is 4 equals to 0 plus K5. So K5 equals to 4. Now we've got the values for the third row. Now we'll be calculating the values for the first row. So C12 equals to R1 plus K2. So 1 equals to 0 plus K2. That implies K2 equals to 1. Now C15 R1 plus K5. So 4 equals to R1 plus 4, therefore R1 equals to 0. Now C21 into 4, that is the second row. So C21 equals to R2 plus K1. C21 value is 2, so 2 equals to R2 plus 3, that is R2 equals to minus 1. So C24 equals to R2 plus K4 implies C24 value is 2 is equal to minus 1 plus K4, therefore K4 equals to 3. Simple is that you have to allocate these values to the stone squares using the formula as I told you for these three. Similarly, we calculating the remaining values. So here you will be getting the values of R1, R2, R3 and K1, K2, K3, K4 and K5. Okay. So now what we have to do is, okay, so this R2 is minus 1, just take a note of it. So now what you have to do here is third, you have to calculate is NCC, that is the net cost change for water square, that is unallocated sales. For this you're using a formula NCC equals to Cij minus Ri plus Kj. Okay, so if you see here, the water squares are nothing but where the allocation is not done. So this is 1 1, this is 1 3, and this is 1 4. Okay, then this is 2 2, 2 3, 2 5, 3 1 and 3 4. So these are the, you can say 1 2 3 4 5 6 and 7 8, total 8 values you need to calculate. So this will be the net cost change calculation for the water square. So now what we will be doing is we'll be using the formula as Cij, that is net cost change, is equal to Cij minus Ri plus Kj. You have already found out these values, and Cij will be cost at that particular cell value. So I'll just explain you first one. So D11 we have taken because there is no allocation at that place. So D11 is equal to, I will calculate it, C11 minus R1 plus K1. What is the cost at C11? What is the cost at C11? You can see here it is 4. Okay. So C11 is 4, R1 value, you know, R1 value is 0 and K1 value is also known to you. So the K1 value is 3, okay. So 4 minus 0 plus 3 gives you 1. So in a similar manner, D13 equals to C13 minus R1 plus K3. So what is the cost at the D13? So D13 cost here it is 3, okay. So D13 is 3. So now you'll be writing it here as 3 minus R1 value is 0, K3 value is 2, that is equal to 1. Now D14 equals to C14 minus R1 plus K4, that is equal to 4 minus 0 plus 3, that is equal to 1. Now D22 is equal to C22 minus R2 plus K2, that is cost at C22 is 3 minus R2 value minus 1, K2 value 1, that is again equal to 3. D23 equals to C23 minus R2 plus K3, that is equal to 2 minus R2 value minus 1, K3 value 2, that is equal to 1. D25 is equal to C25 minus R2 plus K5, that is equal to 3 minus R2 value minus 1, K5 value 4, that is equal to 0. D32 is equal to C32 minus R2 plus R3 plus K2, that is again 4. And similarly, D34 value we have 1. Now we have to check the last column. If you see here, all NCCs are greater than 0 or equal to 0. If you see all NCCs are less than equal to 0, then optimal solution is not reached. If all values are greater than 0, then the optimal solution is reached. But in if case all the values are positive but at least one value is 0, then alternate solution exists. So this is our case number 3 where all values are positive, optimal solution is reached, but one value is 0, so we have to find the alternate solution. So here since all NCCs are greater than equal to 0, there is an optimal solution, but one NCC is 0, so alternate solution exists. Now in order to calculate the alternate solution, we draw the loop which is starting from the lowest cost. That is D25 was having the lowest cost, okay. So this, remember, this is the water square, there is no allocation, okay. So now what you have to do is you have to draw a closed loop which should start from the water square, but the intersection should be present at the stone square, okay. So we'll see how to do this. Now if you see 3, from 3 I can go to 15, from 15 I can go to 45, but at this 3 to return back I don't have any stone square here, okay. So I cannot use this path, okay. Now again if you see here, from here I can go here, I can come back and complete this loop, but there is no any allocation here, okay. So this way and this way I cannot do. So I'll go from 3 directly to 17. I got a stone square here. From 7, this 2 place, again I got a stone square here. From here I got a stone square, but I cannot return back from here. So I will go back to 15. So I have completed my loop with starting from water square and 3 points where I had the stone square. Okay. Now after I get the loop, we have to start with the plus sign from the first value, that was the water square, then minus, plus, minus, alternatively plus, minus, plus, minus. Okay. And now what you have to do is we have to check the negative sign values. We have to see the allocation which is present here. Okay. If you see the allocation present here is 17 and 15. So minimum value of 17 and 15 at the negative sign is 15. So what you'll do is you'll subtract 15 at negative sign place and you'll add 15 at the positive sign place. So here in this case, 15 will be added at this water square, it will become 15. Here 17 minus 15 will become 2. Here plus sign is there, so 15 plus 5 will become 20, and here 15 minus 15 will become 0. So you'll get a new allocation table. So here you can see I've written here assign plus minus signs alternatively and draw a closed loop which should cover the stone square, and find the smallest value at negative sign and subtract it at negative sign and add it at plus sign. So we have got 15 here. So now the table changes as I've just given a square bracket to understand the changes in the allocation. If you remember, a loop was being drawn in this way where it was 15 minus 15, so 0 became here, so there is no allocation at this place. Here the new allocation has come, that is 15. Then it had become 17 minus 15, that is 2, and here it was 15, 15 plus 5 equals to 20. So now we have got the alternate solution here. And now again we have to check whether the IDFS is coming same or not. So if you see, after we get this IDFS is same as the 290 units. So this is the way to solve the IDFS after with the Modi method. Just to remind you, the steps is step number 1, you have to check for the allocation whether it is equal to n plus n minus 1. After that, you need to calculate the values of Ri plus Kg with the formula Cij equals to Ri plus Kj. After that, you need to calculate NCC value, that is net cost change, for the water squares, where you will be using the formula Cij minus Ri plus Kj. After that, you need to see the examine the values of NCCs. If all NCCs are negative, or if at least one NCC is negative, the optimal solution is not reached. Then if all NCCs are positive, then the optimal solution is reached. But if there are all NCCs greater than 0, but at least one value is 0, then alternate solution exists. In order to draw the closed loop, we have to find the NCC with the minimum cost or the minimum value. So, and we have to draw a closed loop which should start from water square and it should intersect or cover all the stone squares at the all edges. And after that, you need to allocate plus minus sign alternatively, and you have to find out the most negative value, or sorry, we have to find out the least value at the negative sign. You have to subtract that least value at the negative sign. You have to add that value at the positive sign. You will get the reallocated table, and still you have to see whether the loop is correct or you are getting the solution or not, and you have to continue this till you get the optimal solution. Okay, so these are the steps to solve the problem using Modi method. If you have any queries related to this, please let me know, and I thank you for watching this video. Thank you.